Now today study about set. In previous classes, normally in 10th class, we know what is set and what are the uses of set. Now in 12th class, we study about sets. So set means what? Set means it is a collection of well-defined elements. So set is defined as collection of well-defined elements. Well-defined elements. Now, what is well-defined? Set, if you take a set or say a set or give an example of a set, that means the elements are well known. In a set, elements are well known. If elements are not known, not defined, that is not well defined, then it is not a set. As for example, suppose A is a set containing elements 1, 2, 3, 4. Now, in this set, we take 4 elements 1, 2, 3, 4. We take another set B, that is element A, B, C, D. Now we take another element C. We take no elements, but elements are defined. We cannot take elements, that is no elements. And we take another element D, that is a triangle. We take a circle. We take 1. We take a bird. Now, this is a set. A set, it is contained a triangle, it is contained a circle, it is contained a real number, and it is a word. So if you say a set, that means the elements must be well defined. If elements are already known to you, if elements are not known by us, hence we cannot say it is a set. Let an example. Suppose we say set of big trees. Now here the elements are not defined. So which tree is big tree? Which tree is small tree? The word big is not well defined. So we are in confusion. Can you write mango is the big tree? Can you write coconut is a big tree? Can you write palm is a big tree? So if you write the mango tree and palm tree and coconut tree, these are the elements of the set of big trees. So it is false. Since the word big is not well defined. Big means that it is not given by us, that by the question, it is not given. The how length tree is, then it belongs to big trees. 25 foot, 30 foot or 50 foot. So a tree having 50 foot is a big tree, and the length of mango tree, palm tree, coconut tree are given, then we say which is big tree or which is small tree. As the word big is not well defined, as the word small is not well defined, so set of big trees, set of small trees, set of intelligent students. So these are not a set, as the word is not defined. If in a set, if element we cannot retain the elements, then it is not a set, and the word is not well defined. Set of intelligent students in your class, set of good students in your class. So the word is not well defined. That means set is defined as the collection of well-defined elements. When elements are well defined, that collection is a set. So we know what is a set. In the set, the elements are written by small letters, and name of a set always are the capital letters. So we take N is a set of natural numbers 1, 2, 3, 4. That you take A is a set, elements A, B, C, A, B, C, and it is named by A. So naming of a set must be capital letter and elements must be small letter. If you take B is a set, elements 1, 2, 3. Here, 1 is an element of B, we write 1 belongs to B. 2 is an element of B, we write 2 belongs to B. 3 is an element of B, we write 3 belongs to B. Here, 4 is not an element of B, we write 4 does not belongs to B. 5 does not belongs to B. Here, this is a symbol of belongs to. If A1 is an element, we write 1 belongs to B. Here 4 is not an element, we write 4 does not belongs to B. So now we know what is the set and what are the naming of a set and how we write the elements of set. In a set, elements must be small letters and the name of the set must be capital letters. Set is described by two edges, two methods. That is, set is expressed by two methods. One is that is list method, other is rule method, or that is roster form or tabular form, rule form or set builder form or set specification form. Now, set is expressed by two forms, two methods. A set is expressed by two edges. One is list, other is rule. List form or roster form or tabular form. So, what is roster form or tabular form or list form? In this form, the elements are separated by comma. These elements are separated by comma and enclosed by a curly bracket. In a set, when we express by roster form or by tabular form or by list form, then elements must be separated by comma and enclosed by a curly bracket. So now he is a set enclosed by a curly bracket and elements are separated by comma. We take another example. A is equal to 1, 2, 3, 4, 5. Here we see, we take the elements by form of list and all elements are separated by comma, enclosed by a curly bracket. So these are the example of a set by list form or tabular form. If you write in rule form, then we write V is equal to X such that X is an vowel. X is an vowel in English alphabet. English alphabet. So V is equal to X such that X is a vowel in English alphabet. X is a vowel in English letter. That means we know A is an English letter, that is a vowel. So A belongs to set. E is an English letter, that is a vowel. So E is an element. In this way you write the elements A, E, I, O, U. But here the elements are not given. The set is expressed by rule. Another way, a set is expressed as a set. The elements are 1, 2, 3, 4. So we write A is equal to X such that X belongs to N and X greater than 0, less than 6. Here we cannot write the elements directly or by list. In this form, the elements are not written by list, not written by tabular form, written by rule. The element of A is equal to X such that X is a natural number and X belongs to 0 to 6. X greater than 0 and less than 6. That means elements are 1, 2, 3, 4, 5. So in this way, we express a set either in list form or in rule form. Now we know that a set that is expressed by two ways. Next, we know the types of sets. Types of sets. Types of sets. First, singleton set. Singleton set. A set is called singleton set if it possesses only one element. If a set possesses only one element, then it is called singleton set. Example, A is equal to 1, B is equal to 2, or C is equal to A. Here we find all sets are containing only one element. If a set containing only one element, then we say it is singleton set. Next, if a set containing no element, that is called empty set. That is called empty set. Empty set or void set or null set So a set is called empty set or void set or null set if it possesses no elements, and it is denoted by symbol phi. Phi is the name of the set which contains no element. That is, the empty set, void set or null set are denoted by symbol phi. Phi is the symbol of empty set, that it contains no element. So we write phi is equal to a set having no element. We express this in form of list or Husserl form. Again we write phi is equal to x such that x belongs to n and x greater than 1 less than 2. Here the elements are also phi. Now we write the empty set by property or rule. Now we express the null set by two ways. First is list form, second is rule form. So we know empty set or void set or null set having no element. Next, what is finite and infinite set? If a set containing finite number of elements 1, 2, 3, then it is finite set. If a set containing infinite number of elements, then it is called infinite set. If a set containing finite number of elements, then it is finite set. If it is contains infinite number of elements, then it is infinite set. Next we proceed the subset, proper subset, superset and power set. So what is subset? Subset. A is subset of B. If X belongs to A implies X belongs to B, then we say A is subset of B. If A is subset of B, if and only if all elements of the A set is also an element of B set. If each and every element of A set A is also an element of set B, then we say A is subset of B. A is an every element of A. If E is an every element of A, is an also an element of B. Here A is subset of B. Subset means part. A is part of B. If E is an every element of A, is an also an element of B. Then we say A is subset of B. So A is a subset of B means if X belongs to A, then X belongs to B. If X does not belongs to A, then there may be X belongs to B. If X does not belongs to B, then X does not belongs to A. In case of proper subset or subset, if X belongs to A, then X must belongs to B. But if X belongs to B, so we cannot say that X belongs to A. And maybe or may not be. If the element does not belongs to B, we cannot find X belongs to A. If X does not belongs to B, then X does not belongs to A. But if X does not belongs to A, then there is some possibility that X belongs to B. Let an example. Suppose A is equal to 1, 2, 3. And here we take B is equal to 1, 2, 3, 4, 5. Now you see that each and every element of A is also an element of B. So here A is a subset of B. In case this subset is called proper subset or part. So A subset is called proper subset if A is not equal to B. If A is not equal to B and each and every element of A is also element of B, then we say this is proper subset. Suppose A is equal to 1, 2, 3 and B is equal to 1, 2, 3. Here A is subset of B and B is subset of A. And here we cannot say this is A is proper subset of B. So in case of proper subset, A is not equal to B. So we know what is subset and what is proper subset. If A is subset of B, then B is superset of A. If A is subset of B, suppose A is equal to 1, 2, 3, B is equal to 1, 2, 3, 4, 5, 6. Here A is subset of B. If A is subset of B, then we say B is superset of A. Superset of A. Now we know what is subset, what is proper subset, and is superset. Now we proceed power set. Power set. Power set is defined as set of all subsets. Set of all subsets. Set of all subsets. Set of all subsets of a set is defined as power set. Let an example that A is equal to 1, 2. Here you see we take a set having two elements. So now the set of all subsets of the set is equal to the power set of A. Set of all subsets. We can taking one is an element, is a set containing one element, it is a set containing two element, it is a set containing 1, 2 element, and a phi is a subset of every set. If you write in the form of a set, and it is called power set. So power set is defined as set of all subsets. Set of all subsets of a set is defined as power set. Now we see that when cardinality of A is equal to 2, this implies cardinality of power set is equal to 4. That is 2 to the power 2. If A set containing 3 elements, A is equal to 1, 2, 3. Now the power set of all subsets, we take 1 is a subset, 2 is a subset, 3 is a subset, 1, 2 is a subset, and 2, 3, 1, 3 is a subset, again 2, 3 is a subset, again 1, 2, 3 and 5 is subset of every set. Now find the 8 elements, the power set containing 8 elements. If the cardinal number of A is equal to 3, then cardinal number of power set is equal to 8, that is equal to 2 to the power 3. Now we may remember that if cardinal number of a set is equal to n, then power set of cardinal number 2 to the power n. If a set containing n number of elements, then the power set contains 2 to the power n number of elements. Now here we know that what is power set, that is set of all subsets. Cardinal number means the number of elements present in the set. Suppose a set containing 2 elements, then this cardinal number is equal to 2, or order of A is equal to 2. This means a set containing 2 elements. Now write B is equal to 1, 1, 2, 2, 2. Here the cardinal number of the elements are 2. It contains 2 elements. It contains 2 elements. So the cardinal number is equal to 2. Now if A set is written, we can find the cardinal number. Cardinal number means number of elements. Number of elements present in a set. If a number is repeated, then the element is 2. 2 is repeated 4 times. It doesn't change the set. Now, we know that if a set containing 3 elements, the cardinal number 3. Cardinality of a set is defined as how many numbers it contains. The numbers of elements present in a set is called its cardinality. Now, if two sets are equal, by equality of set, if two sets are equal, if and only they possess same elements. Suppose A is a set containing element 1 to 3 and B is a set containing elements 3 to 1. Here A is equal to B as A, B possess same elements. Now take another example. A set containing 1, 1, 2 and B set containing 1, 2. Here A is equal to B. A and B possess same elements. If two sets possess same elements, then they are equal. If two sets possess same cardinal number, if A set having 3 elements, and B set having 3 elements, here they have same cardinal number. Cardinality of A is equal to 3, cardinality of B is equal to 3. So they are not equal and they are not same elements, they are equivalent. So two sets are called equivalent if they possess same cardinality or same cardinal number. Here we know what is set, what is subset, proper subset, superset, power set, cardinal number, and condition of equality, and condition of two sets are equivalent. Next we proceed the operation of sets. In next class we study about the operation of sets. Operation means set union, set intersection, set difference, symmetry difference, and complement and their properties.